So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. Okay, so first question is, the question for the day is split array in three equal sum subarrays. तो जो प्रॉब्लम स्टेटमेंट है वो हेडिंग से ही बहुत क्लियर है. You have been given an array, you have an array in your hand, and you have to split it, you have to divide it, you have to divide it in three subarrays. In three subarrays, that is contiguous parts of array. Subarray means contiguous parts of array. Contiguous parts of array, right? Now you have to divide it such that all of them are equal in sum. All of them are equal in sum. That is, if you're dividing in three subarrays such that suppose first is your a1, then your a2, then your a3, then the sum of elements in a1 should be equal to sum of elements in a2, which should be equal to sum of elements in a3, right? For example, for the given array 1 3 4 0 4, if I take a partition here and then here, then what are the subarrays? So this is my subarray 1, this is my subarray 2, and this is my subarray 3. So subarray 1 sum is 4, subarray 2 sum is 4, subarray 3 sum is 4. All of them are equal, so this is a valid partition. This is a valid partition. But for example, if I take the array 2, 3, 4, and if I want to make 3 subarrays out of it, you can see that there is no particular configuration such that I am able to divide them into 3 equal sum subarrays. For example, if I take a partition here, then here, then here, these are the 3 subarrays only possible. So what is the sum here? 2, 3, 4, not equal, right? So in that case, I will return -1 comma -1. That is, there is no partition equal. But in the case above, there is a partition. So what are the indexes? 0, 1, 2, 3, 4. So I will be returning that I can make a partition at 1. This is my first partition point, and then I make a partition at 2. So 1 comma 2 is a valid answer for the given question, right? Now how to solve it? How to solve it? So basic approach is I have to get three subarrays a1, a2, a3, and all of them sum should be s. If it the sum of a1 is s, then sum of a2 should be s, and sum of a3 should be s. That means the total sum of the array, is let's say sum, which is equals to s plus s plus s, which is equals to 3s. This is my basic ideology, that if I divide the array into three subarrays such that each subarray has a sum of total sum by 3, and this is not integer division, mind you, right? Integer division is not here. That means I have to divide the subarray such that the sum of the current subarray is sum by 3. So for the given subarray, let me take the example again: 1, 3, 4, 0, 4. What can I do? It is very simple. What can I do? I can just say that, like, this is the brute force, this is the optimized, this is efficient, everything is this approach only. I'm not able to figure out any other approach because this is very easy. The concept is s equals to sum by 3, right? So what will I do? I will start from here because I have to include every element. My starting point will be here only, start, right? Okay, let me keep a pointer I. My current s is equals to 0. What will I do? Up until my sum into 3 will equal to sum, I will just add elements. So s equals to 0, add it to it. It becomes 1, I comes here. 1 into 3. 1 into 3, and compared to, what is the total sum? 1 plus 3 plus 4 plus 4, that is equals to 12. 1 into 3 is equals to 3. 3 is less than 12, so I have to move forward. Okay, I will add 3 to it. This will become 1 plus 3 gives me 4. 4 into 3 will give me 12. 4 into 3 will give me 12. Okay, that means this is a valid partition. So what will I say? I will say make a pointer here that this is one of my points, right? I will remember this point for the answer. Now, because I am starting with the second subarray now, my s will again convert to 0. For the second subarray. Okay, my I is currently here. What will I do? I will add it to it. So 4 it becomes. After it becomes 4, I will check 4 into 3 is again 12. 4 into 3 is again 12. So what will I do? I will just say that this is a valid partition. Remember this point as well. Now, after I get two subarrays, first subarray, second subarray, I don't have to find the third point because the third subarray is the remaining one, and it should give you the sum of s. That is equal to sum by 3. So what will I do? I will just check the sum of the remaining elements. If sum of remaining elements equals to sum by 3. Let us name this point as A, let us name this point as B, then return A comma B. If it is not, then else you will return a minus 1 comma minus 1. Another point, the constraint has been given that the array elements are always greater than equals to 0. That means if at any point your S into 3 exceeds your total sum, you can say that minus 1 comma minus 1 is my correct answer. But why do I say this? For example, if we look at the second example, 2, 3, 4. What is the total sum? So 2 plus 3 plus 4, which is equals to 9. That means I require 9 by 3, 3 sum here, right? What will I do? My S is equals to 0, my I is here. I will add it. 2. 2 into 3 is 6, which is less than 9. Okay. I come here, I add it here. 5. Now, 5 into 3 is equals to 15. And I have a total sum of 9. Right? That means 15 is greater than 9. That means, and we already concurred that no valid partition is available here, right? So what can I say? If I at any point encounter a sum of greater than 9, greater than the total, greater than the needed, I will say, hey, not possible. So minus 1 comma minus 1 is my correct answer. Minus 1 comma minus 1 is my correct answer. But this is only true when array elements are given to be greater than equals to 0. If it was for less than 0 also, then it would have been a problem and I have to deal with it separately, right? Okay. So very simple, we have discussed the algorithm and it's time for us to see the code. I don't think that pseudo code is required here because this is simple brute force hard coding, right? Let us move to the coding section. So here is the coding section, guys. Starting with the code, I will just say int sum equals to 0, right? And now I will just calculate whole of the sum. So for auto it in the array sum plus equals to it. This will give me the total sum, right? Now my current sum I'm taking as equal to 0. I will take my first partition as minus 1 currently, second partition as minus 1, right? I will assume that there is no valid partition, and if there is, I will just return them, right? What will I do? I will say my current pointer, which was I was taking as I am taking it as ptr, in ptr equal to 0. Now while my pointer is less than array element, that is it is in bounds, what will I do? I will just add the element. So current cur plus equals to arr ptr. Now, two conditions can happen. If my current multiplied by 3 equal to sum. Excuse me, why I am not using sum by 3? Because that may lead to not an integer division. Sum might not be divisible by 3 and that would give me an error, right? So, if my current multiplied by 3 is equal to sum, that means that first subarray might be a good possibility. So, what will I say? I will update my first. So, first equals to I. First equals to ptr. After that, update your ptr and then break. That you have found your first subarray, right? Else if this particular term curl multiplied by 3 is greater than sum. If it is greater than sum, that means you have to return minus 1 comma minus 1 because there is no valid partition for the given array. Else just move on, right? Because you have not yet found equals to or greater than, right? Same thing with second partition. So current equal to 0, and while my ptr is less than array dot size, what will I do? Yeah, what will I do? I will say current plus equals to arr of ptr, and if current multiplied by 3 equals to sum, then second equals to ptr, and then I can increment my ptr and then I can break off. Else if it has exceeded, so current multiplied by 3 has exceeded my sum, in that case again return minus 1 comma minus 1. The situation can end at this return also, at this return also, but if it does not end, that means I have to else ptr plus plus, that is the normal thing. Otherwise, if both first and second pointers have been allotted, that means I have to check the remaining subarray. So again current equals to 0, and now while my ptr is less than array dot size, what will I do? Just a simple thing, I will just have to say current plus equals to arr of ptr, right? If my current multiplied by 3 equals to my sum, in that case that means first and second partition were actually right. So return, what do I return? First comma second, because they were updated in the above loop only. Else what do I return? Else I will return minus 1 comma minus 1, right? Let us try to compile and run it. Hope it will work fine and will not give any error. Oh, there is an error. What is the error? Let me see, guys. Oh, here is the error. I have not incremented the PTR here. Let me run it again. Hope it will work fine now this time. Okay, running fine for the sample test case. Let us see for the hidden test cases as well. Okay, so thank you for watching. Hope you liked it and make sure to subscribe to the channel and stay tuned for the further updates. Thank you. Have a nice day.